It's the first episode of Excursions to Library, but ironically today we are not in our library, but conveniently in my home. Here, I get to talk as loud as I want and move my hands around without people looking at me and thinking perhaps that I am a lunatic. Last week, as I went to the library, I checked out this book. It's called The God Particle by Leon Letterman, and it's a fantastic read. I highly recommend it. It got me thinking about, from the 70 million atoms that can fit on the tip of a pencil eraser stub to the 200 billion stars in the universe. Do we really know what is going on in the extremities of our universe? This is part uno of a series. The journey looking for the atom is a very, very epic journey. So Galileo, the experimenter, formulated the first scientific mathematical equation. That is the equation of gravity. Before the 1600s, the concept of a universe was actually very primitive. The Ptolemaic and Aristotelian view of the universe, which consisted of the entire universe circling around the Earth. Backtracking. So there was Brahe, who was like a measurer's measure because he measured things very meticulously. He gathered up tons of astronomical research. The Danish king gave him funds to build huge observational things, like an atom smasher of our time. Without a nose, Tycho Brahe, unfortunately, he was not a very good mathematician, and he left his math to his successor, Johannes Kepler. Kepler, of course, shed light by adding 3 laws of planetary motion. However, his genius was spluttered and obscured by his religious and spiritual clutter. The exact same year Galileo died, another genius replaced him. That genius is Newton. And you can't go on through the history of physics without discussing Newton. 2,000 years after Democritus theorized the existence of atoms, J.J. Thomson finally found the electron. But this electron was so goddarn small. I'm sure you have heard about Bohr, Schrodinger, and Heisenberg in your chemistry class, so we'll skip the details. What if there was a bigger theory than gravity, a bigger theory than motion, bigger theory than Einstein's? To explore the atom even further, we have to talk about quantum mechanics. And the 3 things that you gotta know about quantum mechanics are: 1. It's spooky and counterintuitive. It doesn't follow the rules of classical physics. But 2, quantum mechanics have been shown to work. But despite the fact that it does work, it has also raised major issues. Einstein would ask a question to attack the fundamental principles of quantum mechanics, and Bohr would try to answer them, back the quantum mechanics principles up. Despite the fact that Newton was right, Newton was inconclusive. Einstein's theory was more conclusive than Newton's theory. And in the same way, quantum mechanics is more conclusive than Einstein's theories. Despite the fact that more things within the atom is being explored, a whole new can of worms is opened. As Rutherford predicted, maybe we can smash particles together to discover things more fundamental than atom. Maybe we can utilize E equals mc squared and turn energy into little amounts of matter. Because E is the speed of light, which is 300 billion miles per second, in order for physicists to create matter. Therefore, physicists have predicted that the more energy you use to smash atoms and fundamental particles together, the bigger the bang, the smaller and the more elusive the particle is. The more energy is needed to hit 2 particles together and smash and create leptons and bosons and quarks. Our idea of a small universe is constantly being redefined. See you next time!